Today let's understand stateless design pattern in Kubernetes. In Kubernetes, a stateless design pattern refers to applications that do not retain any state between individual requests. Each instance of application can handle any request independently without needing to rely on any prior interaction or data. Stateless applications are ideal for horizontal scaling because they can easily be replicated across multiple instances. If we take a simple example, user or client will make a request to Kubernetes service load balancer. It will it can go to any of stateless pods 1, 2 or 3 and states for these stateless pods will be maintained in some external database or cache. Now let's understand what is the purpose of this design pattern. The primary purpose of a stateless design pattern is to ensure that applications can scale out easily and efficiently by not maintaining any state. Each instance of application can independently handle incoming requests, making load balancing and fault tolerance simpler. This design pattern is commonly used for web servers, microservices, and RESTful APIs. Now let's understand how to use it. First, you need to design an application. Ensure that your application does not store any state locally. All session data, user information, and other stateful data should be managed externally, typically in database or a distributed cache. Then create a Docker image. Package your stateless application as a Docker image. Ensure that image is optimized for quick startup and minimal resource usage. Then define Kubernetes deployment. Create a YAML file for Kubernetes deployment. This will define the desired number of replicas, Docker image to use, and other configurations. A sample YAML file is given here. It has replicas 3. It has selector for stateless app. It will select, and then it has a basic details as what should be the container port. Then comes you have to apply this deployment. Use kubectl apply command to create deployment in your Kubernetes cluster. Then next step is expose this deployment. Use Kubernetes service to expose your deployment to network. Here if you see, it will accept request on port 80 and target port is also defined on which it will be redirecting requests to, which is 80 here. Then let's understand pros and cons. First pros is scalability. Stateless applications can be scaled horizontally with ease. Simplicity, easier to manage and deploy as each instance is identical. Fault tolerance, if an instance fails, another instance can take over without any loss of state. Load balancing, load balancers can distribute requests evenly across instances without concern for affinity. Then let's understand few cons. External state management requires external systems, database, cache to manage state, which can add complexity. Then comes network latency. Accessing data from external database or cache may introduce latency. Last one is data consistency. Ensuring data consistency across multiple instances and external state stores can be challenging. Let's understand few best practices. Use databases distributed cache example Redis or object storage S3 to manage state. Idempotent operations. Design your application operations to be idempotent, meaning that repeating an operation will not alter the result beyond the initial application. Session management. Use token-based authentications like JWT or session storage solutions that do not rely on individual instances. Health checks. Implement robust health check to ensure that only healthy instances receive traffic. CI/CD pipeline. Use continuous integration or continuous deployment pipelines to automate the deployment of stateless applications. Monitoring and logging. Implement centralized logging and monitoring to track the performance and health of your stateless applications. Configuration management. Use Kubernetes config maps and secrets to manage configuration and sensitive data separately from the application. Let's understand few use cases. Web servers, stateless web servers that handle HTTP requests without retaining any user session data locally. Microservices, small independent services that perform specific functions and do not retain states between requests. RESTful APIs, API that respond to HTTP requests and rely on external system for state management. Batch processing applications that handle data processing tasks without needing to retain state between individual jobs. CDNs, content delivery networks, stateless edge server that cache and deliver content to users without retaining their state. Job queues, systems that distribute tasks to worker node where each worker processes takes task independently. So this is in-depth guide how to implement stateless design pattern in Kubernetes.